Welcome to our lesson on section 2.3, calculating limits using the limit laws. In this lesson, you'll learn how to use properties of limits and algebraic techniques to evaluate limits. Let's start with the basic limit laws. Suppose a and c are constants, and the limits of f and g as x approaches a both exist. Then the first two properties say that the limit of a sum is the same as the sum of the limits. And along the same lines, the limit of a difference is equal to the difference between the limits. You can see that the other properties state similar ideas about products and quotients. We'll be using these all the time without really thinking about them. If we're lucky, we can just apply the direct substitution property to evaluate a limit. This property says that we just plug in the value of a to find the limit. However, many times x may approach a value that is not in the domain of the function. Here are some examples of what to try. In part A, you may notice that the numerator factors as x plus 2 times x minus 2, allowing us to divide x minus 2 from the numerator and denominator. 2 is in the domain of the reduced function, so now we can just plug it in for x to get 4. Don't be fooled by part B. We could factor x cubed minus 8 and reduce by x minus 2, but we don't have to because 3 is in the domain of this function. Therefore, we can just start by substituting 3 for x to get 19. The function in part C is the same as the one in part B, but this time 2 is not in the domain of the function. This time we do have to factor and reduce so that we can plug in 2 for x. And this limit is 12. Finally, in part D, 1 is not in the domain of the function, and factoring doesn't appear to help us here. Since there's a radical in the numerator, we can try rationalizing. The conjugate of root x plus 3 minus 2 is root x plus 3 plus 2. So we multiply this by the numerator and denominator. That multiplies to x minus 1 in the numerator. Fortunately, that cancels with the x minus 1 that was already in the denominator, and our reduced expression does have 1 in its domain. Plugging in 1 for x gives us 1/4. This concludes our lesson on section 2.3, calculating limits using the limit laws.